Alrighty, welcome back to another exciting edition of Algebra 2 Trig Flipped Classroom. Tonight we're going to focus on multiplying and dividing complex numbers. A couple of keys tonight. If you feel good about foiling, you're going to be in great shape tonight. If you feel good about identifying a conjugate, you are going to be in great shape. So as far as the multiplication, what might this look like? Well, they might throw a complex number like 3 minus 2i at us, and we're supposed to multiply by negative 5 plus 4i perhaps. That's one example of multiplication. You'll notice that foiling is going to play a major part. And as far as dividing goes, they might throw 3 minus 2i and have us divide by negative 5 plus 4i, and then that's where the conjugate's going to kick in. So that's kind of an overview of where we're going tonight. Now, multiplying two complex numbers follows the same properties as multiplying two simple binomials, okay? And by that, I just mean it, like I said in the last slide, if you feel good about foiling, you're going to be in great shape. Now, a couple of keys here. Watch out, and let's put an asterisk next to this. Watch out for I squareds. You never ever want to leave an I squared in your final answer. Always substitute a negative 1 in for the I squared. And also watch out for I cubes. Same idea. You're never done if you think you have an I cubed in your answer. You could always go further. We're going to substitute a negative I in for I cubed. So let's let the fun begin here. Let's jump on letter A here. And we want to find the following products. So product, of course, means that we are going to multiply. And so I'm going to go first times first is 21. The outer is going to be 6i. The inner is going to be 35i. Whoop, almost caught myself there. And then last times last, and this is where it's going to get most interesting tonight. We do have the 10, but it's going to be I squared, 10i squared. So just to recap there, 5i times 2i gave me not just 10, but 10i squared. Of course, I times I is I squared, just like x times x would be x squared, very similarly. So what I'm going to do is I'm going to combine my like terms in the middle. I forgot the squared, gosh darn it. Okay, and then I'm also going to substitute a negative 1 in for that I squared right there. So now I'm sitting on 21 plus 41i plus 10 times negative 1. So that last term really becomes negative 10, and now I'm going to combine my first term with my third term, and that's going to give me 11 plus 41i is my final answer. So what you'll notice here, quick recap, if you multiply two complex numbers together, typically you'll get a complex number as a result. Alright, so we're going to get a lot of... Jeez, Bailey. I don't know if you can hear him, but Bailey is causing a ruckus. He's throwing his bones all over the place, so we'll see if we can get him here to quiet down. But let's tackle letter B. We're going to go through our FOIL again. So first times first is going to be negative 6. If my outer is going to be positive 4i, because I had a negative times a negative. My inner terms are going to give me plus 18i. And then last times last is going to give me negative 12i squared. So make sure you agree with that last term. All right, let's focus on combining my like terms in the middle. We'll also substitute a negative 1 in for I squared. So I've got negative 6 plus 22i. I don't know why my 2's aren't showing up here. All right, there's a little better. Minus 12 times negative 1. And so my last term really becomes, I forgot my eye there, that third term becomes plus 12. So if I combine the negative 6 with the plus 12, I'll end up with 6 plus 22i. All right, we've got one more to try, and I might shimmy down here and put it at the bottom of my page. All right, so we've got 4 plus I times negative 5 minus 3i. Again, we're just going to go through our FOIL. Watch out for our I squareds when we're all done. So I got negative 20 for my first term, negative 12i for my outer, negative 5i for my inner, and negative 3i squared for my last. Now I'm going to go a little bit quicker on this one. What I'm going to do is I'm not only going to combine the middle two terms to get negative 17i, but I'm going to substitute my negative 1 right now, and I'm going to multiply it by negative 3 to get a plus 3. And then last but not least, I'm going to combine my like terms. I'm going to combine the negative 20 with the positive 3, and that's negative 17 minus 17i. Of course, there is a GCF, but factoring that out is optional. You could certainly stop right here. All right, on this particular slide, I want to investigate a curious result that we get when we multiply two numbers known as complex conjugates. So a complex number is a plus bi, and what would his conjugate be? it would be positive a minus bi. Notice all we're doing is negating that second term. The first term remains the same. And so when we multiply these two rascals, let's see, first times first is going to give me a squared. The outer is going to give me negative abi. The inner is going to give me positive abi. And then the last is going to give me negative b squared I squared. Okay? So take a moment, pause, and reflect on that. See if you feel comfortable with multiplying those terms out. What you'll notice is something really exciting here in the middle is that the two middle terms are identical except for one's positive and one's negative. So when I combine them, they cancel out. And then the last, I'm going to substitute a negative 1 in for that I squared at the end. And so I'm getting a squared. And if I multiply the negative b times the negative b squared times the negative 1, I'll get plus b squared. And ladies and gentlemen, that's my final answer for multiplying a complex number by its conjugate. Notice the answer is a real number. That's extremely crucial later on in the video, is that if you multiply a complex number by its conjugate, you're going to get a real number for an answer. And just a quick recap, what a real number just means there are, whoops, don't lose that, okay? All that means is there's no i's in my answer, okay? There was no more i's, it's just a squared plus b squared, there's no i's, and it's just a plain old real number. All right, some brief practice with multiplying conjugates. Anytime we're multiplying conjugates, we're going to go Florida style, knowing that the outer and inner terms are going to cancel. So on this first example, first times first is 16. Last times last is negative 4i squared. So 16 plus 4, of course I substituted the negative 1 for I squared, gave me 20. And again, there is no I in my answer. That is a real number. I want to really emphasize that. Okay, part B, first times first is going to be positive 25. Last times last is negative I squared. So if we substitute the negative 1 in for I squared, we'll end up with 26. Again, a real number. We have successfully eliminated all of the i's when we multiply by a conjugate. And the last one here. Let's go first times first is 36. Last times last is negative 9i squared. If we substitute the negative 1, we'll get plus 9, which gives us 45. Again, it's a real number. We have successfully eliminated who? Yeah, we've eliminated all the i's. All right, quick recap, and let's put this in words and let's get this documented in our notebook. They want to know what's true about each of the products you just found in the last example with the 3 problems. So real quick, what we were doing was we were multiplying complex numbers by their conjugate. So we were multiplying complex numbers by their conjugates, and what did we notice happened? Okay, 2 things I want to document. Number 1, the answers were real numbers. And what does that mean? Another way of saying that is that we had successfully eliminated all of the i's. So we may have started with some i's, but by the time we got done, we had successfully eliminated all of the i's. And I'm going to put the word all in there. All right, we're going to shift gears now, and we're going to put all of our energy into dividing, okay? And here's what you need to know. And let's make this really stand out in our notebook. When we are dividing complex numbers, let's see here, dividing complex numbers, we are going to, numbers. All right, we are going to multiply the top, known as the numerator, and the bottom, known as the denominator, by the conjugate of the denominator. Okay, make sure we know it's the conjugate of the denominator and not the numerator. All right, in a nutshell, that's everything you need to know about dividing complex numbers, and we're going to go ahead and put that into action and see what that looks like. So on this first one, we're going to multiply, let's see, the denominator is 4 minus 5i, so his conjugate is 4 plus 5i. And so I'm just multiplying the top and the bottom by 4 plus 5i. And then we are going to FOIL the top because they're not conjugates, but we're going to Florida the bottom. Florida just is an abbreviation I have for first and last. And in other words, just skipping the outer and the inner. So as I go across the top, let's see here. First times first was 12. Plus, let's see, the outer was 15i. The inner was 8i. And the last was what? be careful here. It's going to be 10I squared. And on the bottom, let's go first times first is 16. Last times last is negative 25I squared. So I tell you what, I really enjoy these. It's pretty straightforward. There's not much new stuff. As far as my numerator goes, I've got 12. If I combine these middle terms, I'm going to get 23I. And that last term's minus 10. Of course, I substituted a negative 1 for I squareds, both top and bottom there. And so on the bottom, I've got 16 plus 25. Just a little more house cleaning. Combine the 12 with the negative 10, and you'll get 2 plus 23I all over 41. And that's the most simplified answer I've got. I've got no GCF in the numerator, so I can't factor anything out, and therefore I can't cancel anything on the bottom. So you notice tonight is just a lot of good repetition. A lot of good repetition. We really want to be experts at this topic. By the end of tomorrow, we'll come in, we'll work the kinks out, whatever's left over, and we'll really, really dominate this topic. And the number one thing here, we're dividing two complex numbers, so we want to multiply the top and the bottom by the conjugate of the denominator. It's just, and I don't think it's possible to say that too many times. All right, so let's go across the top. I'm going to get 10. I'm going to get 6I minus 20I and minus 12I squared. Across the bottom, first and last, first is 25 minus 9I squared. If I get to going too fast here, hit the pause button. Try working it out yourself and come on back and see what we've got. The numerator is going to be 10 minus 14I plus 12 all over 25 plus 9. My final answer, it looks like it's going to be 22 minus 14I all over, let's see, 34. Uh-oh, that's not my final answer. It looks like this one can be simplified, okay? Step number one is we're going to pull out a GCF of the numerator. All right, don't worry about the denominator yet. Just pull out your GCF. That's going to be a 2. My 22 is going to turn into an 11. My 14 is going to turn into a 7, and that's still being divided by 34. Now go ahead and cancel, or reduce, however you like to say it. So I'm going to say 2 goes into 34 17 times. So 11 minus 7I all over 17 is my final answer. All right, so a little practice reducing there. Let's scroll back up here. Let's go get the second one. I'm going to run out of the room here a little bit, but we'll do the best we can. Let's see, what's the conjugate of the denominator? So hopefully you said 4 plus 10I. Multiply top and bottom. Great, great. This is a great opportunity to hit the pause button and make sure that you can try this one all on your own and see how far you can get. Hopefully you can get at least 80% of the way, if not 100%, and then come on back and see how I did. All right, so first times first was 88, so we're working with some bigger numbers. I had the outer was 220I, definitely some bigger numbers. Inner was 12I, and last times last was positive 30I squared. On the bottom, I got 16 minus 100I squared. Just a little bit of house cleaning here. 88, let's see, plus 232I minus 30 all over 16 plus 100. So let's see, I got 58 plus 232I plus 116. All right, now the question is, who is your GCF? How big of a number can you pull out? Well, I tell you what, I had to work the calculator pretty good. At first, I thought the biggest number I was going to get was a 2, but I kept at it, and I discovered that the GCF was 29. So I factored out my 29. Let's see, my 58 turned into a 2, and then when I did 232 divided by 29, I got 8I all over, and let's see. Yes, this does reduce. 29 goes into 116, believe it or not, 4 times. Oh my goodness, I could have even pulled out a bigger number, it looks like. Boy, that one snuck right by me. Because look at this, I got 2 plus 8I over 4, but that means I'm not done. I mean, I see, I've got more there to pull out. So I could pull out the 2 and get 1 plus 4I. Make sure you've got a 1 right there, all over 4. And let's see, 2 goes into that 4 twice. So 1 plus 4I all over 2 is my final answer. Now, with that being said, we're going to scroll back up here. I'm going to leave, now we're not quite done with the video tonight, but this is the one that you're going to do in your notebook on your own tonight. this part C right here. So you're going to multiply the top and the bottom by the conjugate of the denominator, work it up, clean it up the best you can, and then that'll be the first thing we check tomorrow. But I do have one more problem for you to do here together. So they want to know which of the following represents the reciprocal here. That's our magic word of the complex number 3 plus 9i. So if you recall, a reciprocal is just the flipping of a fraction. If I gave you a divided by b, his reciprocal would be b divided by a. Or, the reciprocal of 2/3 is really 3/2 and so forth. Now, if it doesn't look like a fraction, like a, I could always put it over 1 and then flip it. And that's the case that we have here today. I want you to take that complex number and I want you to put it over 1 and then flip it. So the reciprocal is going to be 1 divided by 3 plus 9i. But we've got a major problem here. And this is what I want you to put a little asterisk in your notebook. We cannot have an I in the denominator. We cannot have, similar to a radical, we cannot have an I in the denominator of our final answer, okay? That's a big no-no. So the remedy is going to be to multiply the top and the bottom by 3 minus 9i, the conjugate again. In other words, what we're trying to do is we're trying to rationalize the denominator, because with the I in the denominator, it's not rational. So what we're doing is we are rationalizing the denominator. In other words, we're trying to get the i's out of there and create a real number. And we proved earlier in the video that if you multiply two conjugates, you're guaranteed to get a real number. So let's go ahead. If I go across the top here, 1 times anything is itself. And if I go Florida style on the bottom, I got 9 minus 81i squared. So that's going to give me 3 minus 9i all over 9 plus 81, which is going to be 90. And then I can reduce it a little bit. So let's see, 3 minus 9i all over 90. And I'm going to pull out a GCF of 3. That's going to leave me 1 minus 3i all over 90. And let's say 3 goes into there 30 times. So 1 minus 3i all over 30. And what you'll notice is, if we go back and look at the 4 multiple choices, they split this up. They divided each term on the numerator by the denominator of 30 and then reduced that second term. So we're looking for 1/30 minus I over 10. 1/30 minus I over 10. Okay, I think we found our answer right here is the one I like. So hopefully we did well. Don't forget to finish that part C on the last slide, and we'll see you tomorrow.